I want to show you how to add and subtract rational expressions, and I think a great way to illustrate the principles of subtracting and adding rational expressions is by looking at how to subtract and add common fractions, because the mechanics are the same. And so for example here, I have 2/5 plus 2/3, and if I want to add 2/5 and 2/3, I know I need to get a common denominator. You may have to think about it for a little bit here, but my common denominator is going to be a 15. Okay, so what I do here to get everything together is I need to convert these things into 15ths in order to be able to compare them accurately. So what I'm going to do for the 2/5 is I'm going to multiply by a 3/3. So in the denominator I get 15, in the numerator I end up with 6 15ths. On the other side I needed to multiply in a 2/2. No, I don't. I need to multiply in a 5/5. 3 times 5 is 15, and 2 times 5 is 10. Now that I have a common denominator, I can compare these well, and I say, well, 6 plus 10 is 16/15. So if I have 2/5 of something and 2/3 of something, stick them together, I have 16/15 of something. I'm going to show you how this relates to rational expressions. Again, the mechanics are the same. You get a common denominator, and then you can add them or subtract them. Okay, so now we're going to work a few examples on adding and subtracting rational expressions. In this first one, we have x squared over x minus 3 plus x minus 5 over x plus 3. And these look a lot uglier than the fractions that we were looking at earlier, but they're really not any more difficult as long as we're careful with our arithmetic. So if you remember, the strategy is that you have to get a common denominator. So for this first one, I know already my common denominator is going to be x minus 3 times x plus 3. And I can see that just from the two parts of my denominators that I have involved in my original. Now what I need to ask myself is, for this first one, for example, what do I need to multiply by x minus 3 to get the common denominator? And so you can think about it for a little bit and realize that you need to multiply in an x plus 3 in the denominator, which means you also need to multiply it into the numerator. So I'm going to have x plus 3 times x squared plus 1 in the numerator over x minus 3 times x plus 3. Alright, now for my second one, it's a similar idea, and I think, okay, what do I need to multiply by x plus 3 in order to get x minus 3 times x plus 3? And we can see quickly that the thing that's missing is the x minus 3. So then I just multiply in x minus 3. So then my numerator of my second term here is x minus 5 times x minus 3. Now all I need to do is FOIL out the numerators combined, and there I have it. Okay, so my first one then, and I'll leave my denominator alone, is x minus 3 times x plus 3. And FOILing out my numerator here, I end up with, let's see, x cubed, and then I end up with a plus 3x squared, a plus x, and a plus 3. Alright, in my second one, I have x minus 3 times x plus 3, and then the numerator I end up with an x squared minus 5x minus 3x, so that gives me a negative 8x plus 15. And I went through that kind of quickly, but just make sure you understand how we got those. Alright, now I can bring those together then, and have a denominator of x minus 3 times x plus 3. In the numerator, I just add the like terms. So as I'm looking across here, I see this is the only x cubed I have, so I just have 1x cubed in the numerator. For x squareds, I have 3x squared and a 1x squared. So it gives me a plus 4x squared. Then I have a plus x and a minus 8x, which ends up being a negative 7x. And lastly, I have a 3 and a 15, which adds together to give me 18. Okay, now a lot of times you want to look to make sure, does this numerator factor here? And since we have a cubed and factor by grouping won't work, this is our answer. There's our answer. Okay, now in part B we have something very similar, but this time we have subtraction instead of addition. But I still proceed the same way. So I need a common denominator, which I can see to be x minus 2 times x plus 1. And I can see then in my first term, what do I need to multiply by x minus 2 to get that? I need to multiply in an x plus 1 If I multiply it in the denominator, I have to multiply it in the numerator. So that's why I end up with x plus 1 times x squared minus 1. Then I have minus. I have my common denominator on the other side, x minus 2 and x plus 1. And I look to see what am I missing up here. Well, I needed to multiply in an x minus 2 to get that common denominator. So I'll have to multiply my numerator by x minus 2 as well. So then I have an x minus 1 times x minus 2. And I'll stop real quick to say, sometimes I have students say, well, look, can't you then cancel out the x minus 2's? And the answer is yes, you could, but that doesn't help you because it brings you right back to where you started up here. So we multiplied in the x minus 2 on purpose, so it doesn't really help us to cancel it out. Okay, so let's not cancel it out. All right, again, now let's FOIL. So I'm going to have my first one, let's see, I have x minus 2 times x plus 1 in the denominator. In the numerator, FOILing out across, I have an x cubed, I have a plus x squared, minus x minus 1. And then I have minus a common denominator of x minus 2 times x plus 1 in my numerator, FOILing this out here. I end up with an x squared. Let's see, a minus 2x minus 1x gives me minus 3x, and then a plus 2. Okay, now with subtraction, there's one thing we have to keep in mind. This negative is being distributed across all the terms in the numerator. So what I tell my students to do is to help avoid a careless mistake. Let's make this a plus, and let's change the sign in everything in the numerator. And that way, I will avoid careless mistakes. So this is a negative 2 at the end here. Okay, now I can combine everything and have one expression, which is what I wanted. I have a common denominator of x minus 2 times x plus 1. In the numerator, I have an x cubed. How many x squareds do I have? Let's see. So there's my x cubed. I have an x squared and a minus x squared. So those zero out. I have a negative x and a plus 3x. So that gives me a plus 2x. And then I have a negative 1 plus a negative 2. So I end up with a minus 3 at the end. Okay, again, this cubic numerator is probably not going to factor for us very well. So we'll just leave it like that. And I hope that makes sense. And again, when you're subtracting, it works just like addition. But I always recommend here, when you're getting ready to combine them, make that a plus and change all the signs in the numerator just to avoid forgetting to distribute that negative. Okay, I have one more example I want to look at. Let's look at part C here. And this one's a little uglier. We have three things. And the denominators are not factored. So before we can bring these together, I think we first need to try to factor the denominators and just see what we're working with. So I have x plus 2 over x minus 6. I can't factor x minus 6 any more than that. My second term, factoring the denominator, two things to multiply give me negative 18, add to give me negative 3. That would be a negative 6 and a positive 3. And then my last denominator, two things to multiply to give me 36, add to give me negative 12. That'd be a negative 6 and a negative 6. Okay, now we haven't had to factor the numerators at all, but I notice here that I have some similarities. I have an x minus 6 in all these terms, but then I have this x plus 3 as well. So I'd have to multiply this and this by an x minus 3. It could be that we can factor out this x plus 3 first of all. So let's try factoring this numerator here and see if that works. So I'm trying to think of two things that multiply to give me 6 and add to give me 5. Oh, and you know what? There it is. I have an x plus 3. Okay, so then the x plus 3's in this middle term cancel. And so now I just need to multiply in x minus 6. Unless, let's factor our last denominator. Two things that multiply to give me negative 12 and add to give me negative 4. That would be an x minus 6 and an x plus 2. So there it is. Okay, so the x minus 6 is canceled there. And if you can't see it very well, I'll rewrite it. You have x plus 2 times x over x minus 6 plus x plus 2 over x minus 6 minus x plus 2 over x minus 6. I have a common denominator, and really I have a lot of the same things, right? So remember I have a subtraction here, so I'm going to flip the sign and flip all the signs in my numerator. So it's x minus 2. And when I combine these now, I have x minus 6. And notice I have this x plus 2 plus a negative x minus 2. Or I'm sorry, let's say x plus 2 plus negative x minus 2. That's going to all cancel out. And so I just end up with an x plus 2 over x minus 6. And there it is. So the simplifying actually made this work really easy for us. I hope now you see that adding and subtracting rational expressions is just the same as adding and subtracting regular fractions. If you have any questions on this, I'd be glad to help. Please let me know, and thank you for watching.